Other aspects that we have faced now are aspects out of the battery packs. So this means battery packs often have the demand to get some functional elements inside, thread studs and so on. And it's not only the functional element that have to be put inside, there's also the demand to have a water and a gas tightness leakage rate. The question is, how can we get this rate? So this means we have to look for a certain solution. TOX PRESSOTECHNIK is able to supply this solution with the clinch rivet stud. We can supply a solution which can create interlock inside one material without cutting through. And due to that reason, it's water and gas tight. Other demands out of the field of the eMobility are to have some good joints with a low resistance and a high conductivity between dissimilar materials. So when you look how you can joint these materials, there you have to take aware about the problem that you have. At the beginning, when you have a closer look to the surface of this material, there you can see that there are some tips, and of course this is the natural roughness of the material. And then you have additionally an oxide layer, and you have some dirt on the layer, which is also naturally there. By putting both of these materials together, only the tips are contacting each other. And in the content of the surface, you might expect you have only a percentage of 3% of a real contact between both of these materials. A big benefit is of using now clinching for a joining method that you have a relative movement between both of these surfaces, and you have a very, very intensive, massive forming process to create the clinch joint. During that and during the forming process, the movement equalizes the tips of the materials and increases the percentage of the contact surface. And due to the high pressure that you will perform, there's also the possibility of micro contacts, even between dissimilar materials. And this creates really good conductivity with a low resistance. And as you can see inside the cross section, there's also a large surface increasement. By using clinching, you have a surface increasement up to from 50 up to 80%. And this is very good for having a clean surface during the forming process. The good question is if this joint is long-term stable for electroconductivity. Therefore, together with the Technical University of Dresden, we have done investigations to see how long-term stable is that joint. We have different joints tested, for example, copper and aluminum, aluminum and copper, and copper, and we put them for thousands of hours at 80 degrees Celsius in an oven, and at a certain steps of hours we measure the resistance to see a change if there's something going to be much worse and worse by the time. Which helps us also is the quality factor. The quality factor is a value out of the literature that gives you a good hint if your joint is long-term quality stable or not. It should be better than 1.5. And this is for all of these investigated joints the case. And we already have plenty of these applications in field. As you can see, we have also fused boxes where we have a few and let's say plenty of clinching joints already inside. And a big benefit is you can use the clinching operation for having a conductivity which is at a high level. It's without heat, it's without a pre-hole operation, and all of these joints that you can see here, you can build a tool set that can produce all of these joints in one stroke. And this is not only what we are doing now. For further applications, we are looking that we are going away from the wires inside the car and that we are coming to the rails inside of the car to having a high transfer of amperage and high voltage.